Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Hi, this lesson is to discuss probability and we will focus on conditional probability. Probability of an event is a measure of the likelihood that the event will occur. So the formula is for a particular event, number of favorable equally likely outcomes divided by the total number of equally likely outcomes. That will give you the probability. And hence, the probability for any event, let's say A, is always lie in between 0 and 1. Right? If 0 means it's not possible to happen. If 1, then it's definitely going to happen. Okay. If A and B are two events, then the conditional probability that A occurs, given that B occurs, is using the formula given here. All right. So the way we write it is event A, a vertical line here, given B occurs. And the formula will be probability of A intersect with B divided by the probability of B. All right. As if like the total number of outcome has reduced to the probability of B has happened or has occurred, then on top of it, what is the probability that A occurs? This is conditional probability. Okay, let's see an example here. Right, a fair die is thrown. Find the probability that the number is an odd number, part A. All right, when we throw a die, it's either getting a number 1, 2, 3, 4, 5, or 6, right? And since this is a fair die, so the number will occur equally likely. So for this particular example A here, if we are getting the event and the number is an odd number, so total number of equally likely outcomes is going to be 6 because there are 6 numbers for a fair die. And to find the probability that the number is an odd number is either a 1 or 3 or 5. And that means there are 3 favorable equally likely outcomes. So 3. And that is the probability of getting an odd number when a fair die is thrown once. And we simplify it. The probability is going to be 1/2. So that is the answer for part A. Now we look at part B. So what is the probability that the number is an odd number, but given that the number is greater than 3? All right, we try to put it down like this. We're looking for probability of getting an odd number given that the number greater than 3. All right. That means according to the formula that we have, supposedly we are looking at probability of getting an odd number and intersect with the number has to be greater than 3. All right, divided by the probability of getting number that is greater than 3. So that is how we calculate out the probability for the conditional probability, right? The keyword here, given. So for the numerator, if we are trying to find out the probability, it's an odd number and is a number that is greater than 3. Greater than 3, we can tell is either a 4 or a 5 or a 6. Right? At the same time, it has to be an odd number, then it can only be 5. So to satisfy the event mentioned here, odd number and number greater than 3, there is only one outcome, which is number 5. And divided by the probability that if we are getting the number that is greater than 3. So if the number is greater than 3, there are only 4, 5, and 6. And hence, there are 3 outcomes. All right. Now, you see, the formula is saying that looking at the probability, right? So now what I'm showing you here is the probability of 1 divided by 3. Let's say, if I try to put it in this way, for the numerator, we are trying to find out the probability when we roll a fair die once, it should have 6 outcomes. Then to satisfy the 2 events, odd number at the same time, it has to be a number greater than 3. Then we have only one outcome, number 5. All right. So for the numerator itself, the probability is 1/6. Okay, now we look at denominator. The probability that a die is rolled 1 time, which is 6 possible outcomes. And what is the probability that this number is greater than 3? So we have 4, 5, or 6, which is 3. All right. So the denominator has a probability of 3/6. And you can tell if we cancel off the 6 here, then we are getting the probability of 1/3 as well. All right. So that is the answer for this conditional probability for part B. So the important keyword when we are finding the conditional probability is this word, given. All right. Whenever the question is asking you to find the probability and is mentioning about given, then we are looking for conditional probability, and we can use this formula to find out. Okay, now we're going to go through a few partial questions that we need to answer using this conditional probability formula. Okay, this is the questions from May, June 2011, Theorem 6.1, question 2. When Ted is looking for his pen, the probability that it is in his pencil case is 0.7. If his pen is in his pencil case, he always finds it. If his pen is somewhere else, the probability that he finds it is 0.2. Okay. Given that Ted finds his pen when he is looking for it, find the probability that it was in his pencil case. Okay, to answer these questions, we will try to illustrate a tree diagram. Okay, first thing, when Ted is looking for his pen, the probability that it is in his pencil case is 0.7. So is in the pencil case. So not in the pencil case. And the probability that this is in his pencil case, 0.7. So which means not in his pencil case, 0.3, right? So the total of these two branches must equals to 1. So either he finds it in the pencil case, probability 0.7, or not, 0.3, and total is equals to 1. So if his pen is in his pencil case, he always finds it. So he can find it. And the probability is 1. He always finds it. So if his pen is somewhere else, then the probability that he finds it is 0.2. So if it's not in his pencil case, so the probability that he can find it is 0.2, which means the probability that he cannot find it is 0.8, right? The two branches total must be equals to 1. Now to find the probability, Ted finds his pen when he's looking for it is given. So whenever it's given, you put at the back because it has occurred. Given that Ted finds his pen, so he can find it. So what is the probability that it was in his pencil case? So in his pencil case. So according to the formula, we are finding the probability that the pencil in his pencil's case and he find it divided by the probability that he find it. All right. So using the tree diagram, we're trying to find out the probability that in his pencil case and he can find it in his pencil case and he can find it. So first, this is the branch that in his pencil case and followed by this branch, he can find it. So this is the outcome that we want to determine. The probability is 0.7 and so multiplied with he can find it 1. All right. And divided by the probability that he can find it. So what does it mean by he can find his pens? First, we have to consider that the pencil in his pencil case and he can find it, which is from here, this outcome, or plus with the pencil is not in his pencil case, but he can find it, right? Which is this branch, which is the probability that 0.3 and he can find it. That this is the probability that he can find his pen. Okay, and hence using a calculator, we can find out the probability. So using calculator, the probability is 0.7 divided by 0.76. And hence the answer 0.921. All right. That is the probability that he can find it given that the pen is in his pencil case.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.